All right, are there any questions before we get going? You all, looks like some of you are already getting going on the get going. So let's take a quick look at the project's assignments. Pipelines. So this assignment should only take, it shouldn't take more than an hour, I don't think, at least that's how much time I was planning on giving it. There, let me see. So it's mostly an exercise in kind of hunting through man pages and figuring out how things work to the extent you don't already know. And this one, so it's in two parts. One is to get this first part going, and then the second part is to just kind of expand it. And so all you have to do, you don't even need to turn in a separate file. You just need to take the two pipelines that you create, and you can actually just paste the commands in this submission field that this thing has. I guess under write submission, you just, I suppose if you attached a bash file, that's fine, but since it's only going to be a couple lines, you can just paste it into this written submission portion if you want. And so that's what I was looking to kick off the class with. Anyone, and then we can kind of debrief on it. Anyone have any questions on that? Pretty straightforward. All right. Then I will let you get started on that. I'll stop the recording and then pick it up after an hour or so, and we'll move forward from there. Okay. Yes? Say it again?
Can I get some help?
Yes. So let's talk a little bit about what we found out with find and xargs. So if I make a directory, I'll call it or some directory. I go into some directory and let me create a file called first. Let me create a file called second. And let me create a directory called private, and let me change the mode of private so there are no permissions. So I say find some directory, and I get that. Let's see. There's a, after the directory that you're going to find, this option here is called the predicate, and I believe print is the default predicate if you don't specify it, but that becomes useful to know in just a moment. So what is xargs doing? What is xargs doing? Huh? No. That's not what xargs is doing. Let me give you a it executes commands. So let me click. Go ahead. All right. So the idea is that you have this pipeline here, and it's some command or whatever you had previously is going to create a list of things, and the problem is you need to process each item in that list separately. And that's what xargs is doing, is it's allowing you to run a command on each item in that list separately. All right? So in this case, I'm getting a long listing of everything coming from this side of the pipeline, and the D means it isn't going to, it'll just list the name of the directory, not the contents of the directory. So that gets me this directory and then each of the files within there. This right here is being generated by the find command, and that of course is an error message, and that would be sent to standard error. So let's talk about the pipeline for a minute. What did we have for the simplified version of the more complex pipeline? So if I take this, so what is the pipeline doing? From a programmer's perspective, from you as, and we haven't, this is stuff you'd get in systems programming and maybe in OS. If you are the author of Bash and you're writing the Bash interpreter, or whatever you want to call it, shell, and this is typed in, what exactly are you doing as the Bash programmer to make this thing work? Let me ask you a different question. What does cut think it's doing as far as where it's getting its information and where what it's doing with its output? It's getting it from standard in and it's sending it to. Right, and so this is a huge part of the whole Unix philosophy, which is create small dedicated tools and have them operate on stuff coming from standard in, and after it's done doing its processing, send its output to standard out. So what the Bash shell is doing is it's forking. You have 1, 2, 3, 4, 5, 6. So there's 6 calls to fork here, right? So Bash is creating 6 copies of itself, and then it's running exec the 6 times to replace the copies of itself with find, with xargs, with tr, with cut, with sort. Grabs those from the file system, brings the image in to replace the process. The way it's accomplishing the whole magic with the standard in, standard out is these tools are not any wiser. They do think they are reading from standard in and writing to standard out. All standard in and standard out are file descriptors, small numbers. Let me see. Maybe I wonder if I can. All right, right here. So let me bring this up. That's what I did. Ignore the S trace. I did an echo hi there, right? By itself, we just see hi there to the screen. What's going on under the hood? I ran S trace, which is showing us all the system level calls that are occurring when you run echo. And there's a whole bunch of crap with loading in libraries into memory and so on and so forth. But you get down to where the rubber meets the road here, near the bottom. And that is this right here. And this is a system call. If you haven't taken OS or haven't taken systems programming, write, and the first argument to write is a very small number, which is a file descriptor of where you want to write to. And here, hi there, is being written to file descriptor 1. And so basically this string is being written and this 9 represents how many characters are being written. So if you counted that up, that'd be 9 characters if you included the new line. And then this is just showing the actual output that occurred. And the reason this is bleeding down to another line is because of that new line. Let me do the S trace again, and the -n suppresses new lines. This output looks a little bit nicer. Now you'll see that there are only 8 characters being written, and those are the 8 characters being written, and then it ends. This, by the way, is what the function returns. Then there's a couple closes and exits. So it doesn't matter whether or not I have a pipe sort there. I mean, obviously there's only one line to sort and it's pretty nonsensical. But let me do the strace again. And we'll note that even though echo is now sending its output not to the screen but to the sort program, the system call didn't change. Echo still is writing to file descriptor 1. So the magic that's actually happening is that the shell is changing what file descriptor 1 is for the echo command. And what it's doing is it's making it so that file descriptor 1 is no longer the screen. It is now file descriptor 0 of sort. So we have standard in, standard out, standard error. That's 0, 1, and 2. Okay? So the programs don't change. They still do what they always do. What's changing is Bash is rewiring standard in and standard out to be to each of these programs in succession. And obviously it's beyond the scope of this course, but to the extent that you haven't had systems programming or perhaps OS. Okay, this is the command. It's called pipe, and it actually does the heavy lifting. It creates a couple file descriptors. What it does is it creates this weird tube where it creates two file descriptors, and it has the output of one become the input of the other. It's this little kind of self-referencing arrow, and then you can run another command to basically turn off file descriptor 1 here and make it this part of the pipe, and turn off file descriptor 0 over here, make it this part of the pipe. Now when this one writes to 1, it ends up going to the input of the other. Okay, so there are system calls that enable this to happen. And that is why when what was I doing, find? So I did find on some directory. Let me do an ls on some directory. It has those three things. Let me do a long listing. When I run this find command, let me clear the screen. Even though I'm piping in here, this is not going to ls-l. Why is it not going to ls-l? Let's do an strace. Let's see if we're going to see it here.
Down under open at FDCW last one there.
Ah, it's writing to file descriptor 2. Remember, it's file descriptor 1 that's going into the pipe. File descriptor 2 hasn't changed at all. It's still going to the screen. Could you, as a programmer, make file descriptor 2 go somewhere else? Yeah, you make it go wherever the hell you want, right? But in the case of Bash, the way it basically doesn't do anything to file descriptor 2. Did the programmers who wrote Bash provide mechanisms for you to change other file descriptors? Absolutely. What you can do is, let me clear the screen again. I can say this, that means make file descriptor 2 go somewhere else. In fact, this means make file descriptor 28 go somewhere else, right? Well, you and I both know that file descriptor 2 is standardized to be standard error, so we can say make file descriptor 2 go somewhere else. I can make it go to a file called errors, and if I cat errors, then, I still have the strace. Where does the output to strace go, do you think? Standard error. That's why that whole thing went. Let me do that again, get rid of strace. Now when I cat errors, I just get that one error went there. A lot of times we are not interested in seeing the errors at all, so the common technique is there's a special file in the file system called dev-null, which is just a bit bucket. Anything you throw into it goes into the nether void, right? And now we don't see the error at all. A lot of times we are interested, so yes, go ahead.
Does it matter if you have the dev null before the
like that. It's just one of the things that Bash is parsing. Now there are well, I won't get into that discussion yet. There are times where the order of things matters. In this case, it doesn't. So I want to come back to this in just a moment, but let me take just a side jaunt. A lot of times I want to do a behavior based on the success or failure of a command. Let me go into some directory here. I've got, if I say ls private, I get an error message. Okay. If I do ls first, I don't get an error message. ls actually gives us a result based on its success or failure. Does anyone know how I can determine whether or not ls worked flawlessly or had an issue? Anyone know how I can figure that out? Obviously, we can eyeball it and see, but if you want to put this in a script, you want to put ls in a script, and you want to figure out, you have an if statement, and you want to figure out whether ls was successful or failed. Yeah.
Does it return something?
It does return something, and it returns it to a variable, a special shell variable. And what is that shell variable, I guess is what I'm asking. So an example of a shell variable would be path, although that's an environment variable, but you get the idea. Echo $? That tells you, that gives you what was returned from the last command. Let me try ls private. Echo $? All right, now you're a programmer and you're writing a program. How can you specify whether or not a command, your program succeeded? How do you make the shell aware of that? As a C++ programmer, you're writing hello world, and you want the shell to know that hello world worked correctly. How do you make the shell aware of that? Yeah, that's the return statement that you have in main, right? So everyone in so right off the bat at 111, this is always here, and everyone just takes it for granted. That is what the shell gets. So this is how you write programs that you can then integrate into shell scripts. So let me take this program and let me make it 6. G++, me.cpp, whoops. Run it, $? And so that's what ls is doing. ls interrogates, in this case, interrogates the directory. It's something screwy, so it returns, rather than saying exit, it will return something out of the program that then the shell can interpret. A lot of times, different numbers will be returned depending on the type of problem. And I'll confess I don't know if ls, let's look for, yeah, it isn't going to say with ls, it doesn't look, exit status, here it is, exit status, I was looking for the wrong phrase. So ls will return 0 if OK. If there are minor problems, it'll return 1. For instance, it can't access a subdirectory. If there's serious trouble, it'll be a 2. Can't access a command line argument, which is what I did when I said ls space private. Okay. So it's up to you on what you return. But it then allows you, if you have some utility of medium complexity, it allows you to build in a fair amount of intelligence that this way you indirectly communicate to a script that will be using your program. So how can we do that? We can say, let's see, let's call this script.bash. ls $1. Does anyone know what $1 is? We haven't talked about this, but we're kind of learning some of this stuff indirectly this way. Let me try about you entered $1. Oops, how about echo, you entered $1. Let me come over here so I can leave that up. I don't know where I am. Where am I? All right. So I change mode. I add execute permissions to script.bash. I run it. Okay, so the numbers are just referring to arguments you type in for your script. So let me do this. So I say ls $1 if now let me use printf that entry is fine. Else there was an issue. So let me run that script. I say script.bash. Let me do an ls. Let me see. First. Script.bash first. Oops. What did I do? Fee. So this is what I want my script to do, but it's messy because I do not want to see this and I do not want to see this. So how can I correct my script so that I don't see this and I don't see this?
Or you could type ls and then don't or null that.
Right. So I would. So let's be clear with terminology. I don't want to pipe. I want to redirect. I want to redirect the output to dev null, and I want to redirect the error output to dev null. All right. So here's a perfect example of I'm very interested in the success or failure of the command, but I don't care about what the command is actually generating as far as output. So now, when I run it, yeah. All right. What about we're looking at this and taking it for granted that that's how an if statement works, but did you know, whoops, what does which do? Tells me where something is. Did you know that that's in the file system? That there's an executable program, that open bracket. So essentially what that open bracket is a shorthand way of using the word test. And this often creates difficulties for people who create test programs and don't realize this. So they'll compile it and name their program test, and then they'll try running test, and they don't understand why their program isn't working. It's because they're running this thing in user bin and not the program they compiled in their current directory. That's one of the reasons why I never include the current directory in my path and force it, so I have to do ./a.out. if I do that for all my 111 students and they name something test, they will have gotten accustomed to typing /test to make sure they're running the correct test program. So you can actually you can do stuff like that. So that's what your square bracket is. It's a shorthand for that. Now there's oh yeah. So now we go back to where I was, which was I was up here. And we're doing that, and we're getting rid of the error output. All right. What if sumdir? Let me go into sumdir. What if I had a file called now the ls command is giving these as conveniences, but if let me see. So what I did is I took the ls command, the output of the ls command, and I redirected it to a file, which I named randomly. There's no significance to FDS. If I look at the contents of what ls produced, note that this is a file name with a space, and this is a file name with a space. I just wanted to make that clear that these single quotes are gratuitous for our human readability. Okay? All right. Now let me run. No, let me get rid of this. It doesn't matter. So what's happening is, let's look at this without xargs. What's happening is xargs is basically separating things on spaces. So it's trying to do a, what was xargs doing? It's trying to do an ls-ld on sumdir 3, and it was trying to do an ls-ld on 4, right? Neither of which exist in the system, so we've got a problem. So now the question is, how can we modify this pipeline so that it correctly handles things like spaces and file names? You can use tr, but we can actually work with what we have here. This predicate has a different version where I put a 0 right after the t. And now what it's going to do is, rather than dividing lines by new lines, it will divide lines using the null character. So let me take this, the output of this find command, and redirect it to some temporary file. Let's look at that file. Now you can see it's sumdir, not a new line, a null character. Sumdir first, a null character. No, there are no more new lines. All the new lines have been replaced by null characters. Okay? That gets us close, but not quite there, because xargs separates things by new lines. Man xargs. Here's an option. Input items are terminated by a null character instead of by white space. Yep, what did I do wrong? There you go. Any questions on that? Okay. So again, the idea here is that you don't have every single option of all these commands memorized. You have an awareness of the existence of a lot of commands. So now you have an awareness that xargs exist if you didn't previously. And you start to have an awareness of these kinds of problems and that there are ways of troubleshooting it. And it's worth going through man pages and looking through options to likely find a solution, because you're probably not the first person to have that kind of problem, right? So there's probably been an option developed to handle that. Or, as was offered, you can just add other things to the pipeline, like TR you can use to translate new lines into null characters and deal with it that way. So what I wanted to leave you with today then, for you to finish up prior to tomorrow, was assignment 4. And I know that some of you are looking at that. Let me talk about it a little bit. I wanted to start by talking about a command called paste, which you might not be aware of. Just out of curiosity, is anyone aware of the command paste? Anyone used that before? All right. Pretty simple. So I can say, where do I want to go? Vagrant, week 1. Let me take this. Week 1, day 3. I want to call this null notes. I'll leave that command there with the print 0 and the null, just so you have it posted with the notes. Let me create first name, SpongeBob, Todd, Mount, last name, SquarePants, Gibson, Shasta, paste, first name, last name. All it does is it takes the first line of one file and the first line of a second file, and it makes them appear on the same line. So it's a way of, it's like shuffling cards, right? It's a way of combining two different files into single lines. It looks like what's being used here is a tab as a separator. My guess is you can change that. If I do a man page on paste, okay. All right. What's more interesting, though, is paste, or paste is join, which is what the assignment's concerned with. And if I do vendors, and vendor 1 is Mickey, vendor 2 is Goofy.
Yeah.
Vendor 3 is Cinderella. Now I'm going to come over here. Vagrant, week 1, day 3. Okay, let me make sure I'm in the right place. So let me vim receipts. And Mickey sold something for $1.98. And Mickey also sold something for $23.45, and Cinderella sold something for 99 cents. So what I want to do with join is kind of a database type thing where I marry the names with the sales, and note that Goofy didn't have any sales this day. So then I can say join. Let me come over here. I can actually do this. week 1, day 3, receipts, over to here, clear, join, vendor, receipts. Oops. And note that it does kind of a database style join to it. And then there are options you can provide to refine it, or if there's a different key. One of the main things to note, what I did is these keys, which happen to be the first character, are in sorted order. So join doesn't do any magic. If they aren't in sorted order, join's going to complain. So when you create these files, or I think there's only one temporary file you're creating, you have to make sure that it's sorted. Also, the assignment is asking you to pipe something in. So one of these is not going to be a file. Let's say that vendors isn't a file. Then what I do is I replace that with a hyphen, and what I can do is say cat vendors, and I can, whoops, so now you'll note that I created a pipeline here, and receipts it's going to grab from the receipts file. However, this file is coming from standard in, which in my example is coming from the pipe. Okay, so that's how you can avoid 2 temporary files, 1 temporary file, and then you have your pipeline going. Okay? All right, so I will let you have a go at that. This is something where it's strongly advised you work on Jaguar, because SSH Tia Gibson Jaguar, because the last command has a lot of nice data to work with. If you're working on your Vagrant box or your own machine, the output of last is not going to be nearly as rich. So definitely do this on Jaguar to get some nice output to work with.